All right, now let's do something a little bit trickier. Let's prove that something diverges. This is tougher because we have to argue that no matter what choice of big N that you might choose, that there is no such choice of big N there. We can't get far enough that we're ever going to converge to any particular value. And so we're going to do that by contradiction. Right? So proof. Suppose that the sequence 2n converges to some value, let's call it s. Right? Let's let epsilon be equal to 1, and then we would have the absolute value between 2n and s is less than 1. For all n that are big enough. And we don't know what big enough means yet. But yeah, for every choice of n that are big enough. Right? And so if we were to take little n to be equal to big N plus k for all k in the natural numbers, we would have the absolute value of 2 times the absolute value of 2 times n plus k minus s is less than 1. And we're going to work this through and see what this implies. It's going to imply something absurd. We're going to get a contradiction, right? So we would have negative 1 plus s over 2 minus k is less than n is less than 1 plus s over 2 minus k. So for our value of k larger than 1 plus s over 2, this requires our value of big N to be a negative value, which is a contradiction. The next thing that we have is boundedness. Our definition: a sequence is bounded. It is bounded if the range is a bounded set. Right? So no matter what choice, no matter what term you have in the sequence, the absolute value of that term is smaller than some particular value for every term in the sequence. Yeah. All right. And so on the next page, we're going to look at some more examples.